Hello, my name is Kimyonghoon. Today I'll be introducing some of our works in relation to the subject artificial vision. I work with Sinseungback as a team called Sinseungback Kimyonghoon. Seungback studied computer science and I studied visual art. Through this engineer and artist collaboration, we've been exploring technology and humanity, its nature, relationship, and future. Among many important technologies, we've been focusing on computer vision, which is a subfield of AI and deals with how to make machines see. It can simply be understood as the eye of AI, the artificial vision. Here are some examples of computer vision applications. Face detection, which is already in your smartphone cameras. And it also recognizes emotions. It's used in self-driving cars and it now diagnoses cancer. This picture compares human vision and computer vision. Human eyes gather the visual information of the tree and the brain processes it. Then we know it's a tree. Computer vision works similarly. The camera collects the visual information like human eyes, and it has the processor which corresponds to the human brain. So it becomes the first visual technology that sees and understands the world by itself without human intervention. Computer vision is not as good as human vision yet, but machines have some advantages over humans. Human eyes only can see the small portion of the light spectrum, the visible light. But machines can perceive much wider spectrum such as infrared rays, X-rays, radio waves, etc. Therefore, they can see things in a very dark environment, and it can even see things through walls. A typical human has only two eyes attached to its head. The machines can use much more visual sensors, webcams, CCTVs, and even satellite cameras. And it can use them all at the same time, remotely through network. The size of human brain is limited to the size of the skull, but a computer can be as big as a building, which means that it can process much more visual data. And its processing power is getting stronger and stronger. When it's connected with the numerous visual sensors around the world, it could have a global scale vision. This new eye will change not just how we see, but also how we think about seeing. Our practice explores this technology as a tool, and more importantly, as a subject. Cloudface is a collection of cloud images that have been recognized as faces by computer vision. We took photos of the clouds every 5 seconds and let the computer see if there's any faces. If it finds a face, it saves the image. These images are actually the result of the technology's error. But the interesting thing is that some of the images look like faces to human eyes too. To human eyes though, it's not an error. We know these are not actual faces. Rather, we imagine faces from the clouds. So here, the error of AI and the imagination of human meet. Let's say the black circle is the universe. Human vision can see some part of it, drawn as the blue circle. And computer vision can see some part of it, the red circle. They overlap in some part. Cloudface belongs to this overlapping area. It's an unusual visual activity, but we see the same thing anyway. Our works explore different areas of this diagram and discuss its implications. Kerohuman is a similar work. These are human faces recognized as cat faces by a cat face detection algorithm. And these are cat faces recognized as human faces by a human face detection algorithm. Flower presents variously distorted flower images that have still been recognized as flower by AI. We start with a photo of a flower and distort it in many ways, and we collect the images that are recognized as flower by AI. And then the images are made as a moving image, one abstract flower morphing into another, as if it blossoms again. Some images look like flowers to human eyes and some are not. There is no right answer to what these abstract images actually are. But AI says it's a flower. What do you say? CAPTCHA Tweet is a web application that posts tweets as CAPTCHA. CAPTCHA is this kind of distorted text you meet when you try to sign up for a website. They make you type in what the characters are. It's a test to find out if you are human or not. If you can read this, you are regarded as a human. If not, you are a computer. Computers cannot read this because computer vision is not good enough just yet. So the test can be used to block harmful softwares. Based on the fact that the characters in the CAPTCHA form is not legible to computers, we used CAPTCHA as a secret communication tool between humans and applied it to social network communication, Twitter. What it does is very simple. It turns your tweets into CAPTCHA. Let me show you how it works. You go to the website captchatweet.com and log in with your Twitter account. Type in your message and click CAPTCHA. If you click tweet, it gets posted in your Twitter timeline. Only humans can read your tweets now. I also find the CAPTCHA itself very interesting conceptually. CAPTCHA is a symbol of humanity in a way, because it's something that can be solved by only humans. But as you can see the images here, CAPTCHA has been changing its shape because computers have become more and more intelligent to read the distorted text. If we distort the text more, humans cannot read it either. So now we needed to come up with another form of CAPTCHA to distinguish computers and humans. Of course, we have many things that we can do much better than computers now. But would it be so in the next decades? Would we have something that can be never mimicked by computers? Non-facial portrait explores the question further. We invited painters and asked them to make portrait paintings of a person based on a photograph. They had to follow one rule. The face of the portrait must not be detected by AI. While the portrait is being made, a camera equipped with 3 face detection algorithms watches the canvas, and a monitor informs the painter if any face is detected. The painter would refer to it and develop the painting. The face of the completed portrait should not be visible to any of the 3 algorithms. It's tricky. If you make the portrait close to the human subject, computer vision will easily detect the face. And if you distort the face too much, the painting would not be seen as a portrait of the person. One must find the small visual space that only humans can perceive. In the installation, each portrait is presented along with a video of the painter's painting process. The originality of humanity is often discussed in relation to AI today, since it's becoming able to mimic many of human abilities. So, what would be the human uniqueness that AI would never be able to mimic? The project was an experiment to examine the question. If painters successfully complete the task, the paintings would represent some kind of humanity. If they fail, it would show the delicate situation humans are facing. AI can hardly find faces in any of the paintings, but do we see the face of the subject in the paintings? Can we say the paintings are a portrait of the subject? It's up to you to decide if the painters successfully completed the task or not. In the near future, we might need to redraw the diagram like this. Computers have become to see most of what humans see, and more. Non-facial portrait deals with this area. It will be more and more difficult to find unique human abilities as technology develops further. It feels like a threat or crisis, but it also could be an opportunity for us to find new human value and understand ourselves better. You can see the rest of our works in the website. Thank you.